Hi everyone. My name is Dr. Anand Anbalagan. Today we are going to discuss the topic linear regression model in the machine learning approach. So the motivation behind the machine learning model is the machine learning nowadays is a plays vital role in all kind of engineering. That's the reason we are using machine learning model as our interest. I'm going to use this session as two part. The thing is outline as mathematical model and Python programming model because before modeling anything, we must know the mathematical complete approach of the system. Then we have to implement into the software. Both things we can do by this lecture. The introduction about the machine learning is that machine learning is a subset of artificial intelligence that focuses on algorithm development and statistical modeling. So that is the main major role of machine learning, developing algorithm as well as the statistical model. So classification of machine learning is three types. One is supervised and unsupervised, and finally reinforcements. Supervised learning is learned based on input and statistical data or labeled data only. So the labeled data is giving some supervision to the input, so it's easily to predict that one. But in unsupervised, input data and unlabeled data are used to predict the future one. So this is unsupervised learning. Reinforcement is there. It's quite interesting. Rewarding desired one and punishing the undesired one. This means that we are reinforcing the desired one again and again. Automatically, we are giving least significant to the undesired one. Obviously, our whatever our desired one is stronger than the undesired one. So it is optimistically we can achieve our own goals. Supervised machine learning algorithm is again divided into two types. One is classification and one is regressions. Classification means predicting the class of the data set, that is the output. Depends the independent data is the input variable, but the regression is that finding the behavior of input and output in a many ways. It may be a linear means it's a linear regression. It is non-linear means non-linear regressions. There are many type of regressions type available. So it is continuously checking the relationship between the input independent variable to the output dependent variable. So linear regressions, so already we mentioned that it is a supervised learning algorithm and it has the relationship between the input and output. The input is always a more independent variable. If it is output is dependent. For example, for this one, sales, salary, age, product price. These are all the example for where the linear regression analysis is required. So this is the illustrative idea for linear regressions. You can see independent variable and the dependent variables are plotted x and y, and this line is represents the behavior or the relationship between the input and output, and the scattered data are labeled data, which is observed data. So if they are in line with with the the line of regressions, if the data model is absolutely correct, or the scattering distance is maximum, obviously the model is not powerful model. This is the validation of model by using the scattering plot. The mathematical part of linear regression is that it is simply a line equation. Of course, see here, the line only is there. Line equation. Line is y is equal to mx plus c. This is a m is the slope, c is the intercept. So a and b, a here as the intercept, b here as a slope. So a and b's are here. You can see clearly this is the cross correlations, and these also the cross correlations and autocorrelations also there. So the intercept and the slope of the equation is being calculated and derivated from the correlation function. So the regression is derivated from the correlation function. That is a beautiful idea of the statistical approach in the mathematical part of linear regressions. So the multiple linear regressions is the real-time linear regressions because in real time we have more number of features to predict it. So n number of features to be predicted. So mostly the real-time problem is multiple linear regressions only. For easy approach understanding purpose, we are going to see the simple linear regressions for our explanatory part. The cost function of the regression is that. So it's a parameter. The parameter of linear regression is that. So mean square error and absolute error and root mean square error. So why the parameter is required? Because you have to see here. So the minimum mean square error is that this is our, for example, I'll take the pen. Yeah, this is our variable x, and this is that y. So in this case, our relationship is here, and this is our line of regression, and this is my labeled data or statistical data. This is my predicted data. Assume that this is here my predicted data. So the distance, Euclidean distance between the predicted data and the labeled data is known as error E. So the error is, what is error is that the error is the difference between y, that is a statistical data, and WT, the weight coefficients, with my x, and this Euclidean distance. This is square. Euclidean distance is a square one. So this mean square error, which is minimum, means to be 0. So this is that mean square error makes my system to be perfect. So how much we are reducing the error is our part, is our algorithm. So this is the mean square error part. How we are making the minimum one is clearly given. So the next thing is, we must know one more mathematical approach for linear regression is that is updating the minimum error. So the linear regression model can be used as a gradient descent method to reduce the mean square. How it is to be reduced the mean square error is that. So it is interesting. Just give me a couple of seconds. So same thing we are going to use here. For this is my x, independent variable, y is a dependent variable. It may be a time, this may be a salary, and we found the relationship between the equation y is equal to mx plus c, and m and c's are calculated by the equations, and the minimum mean square error is reducing the error. But the problem is my data scattered here. If I use this is my line, means it won't be work out. So my line should be here. Wherever the data is scattered, my line should be there. So my line should be updated depends upon the behavior of the data. So updating is done by gradient descent method. In this method, we are increasing the step size and decreasing the step size to until the optimization is required. So this is the how the gradient descent method is used for reducing the minimum error. The algorithm for this one is updating algorithm for this one is the gradient descent algorithm. So repeat until the conversion. This is that the step size and the data values is updated here. So this can be keep on iteratively running until the convergence is required. So this is make this total linear regression analysis into the higher efficiency and high convergence level. The simulation is the interesting part of the model. We are going to simulate by using Python program. So first, for data pre-processing, we have to do fitting and the linear regression sets and prediction test results, and finally visualizing training set results and visualizing test results. This is the 5 part of our Python model, which is equivalent to the linear regressions. First of all, we are in Python model. Everyone knows we have to import the library. NumPy is used for numerical all kind of library inside, and matplot library is used for plotting purpose because we are going to visualizing, and pandas is used for data classification or data all kind of data set manipulation. All operations can be done in pandas. So data sets, we can you see here the data set. Um, the data set, yes, data set is come in the PD. The PD dot read. I mean, using the Panda only, we can read the data sets, and after that we have to allocate and extracting the data from the total data sets. So that is given here, iLook. So by using that, we can extracting the data here, and the data sets you can see. the years of experience and salary. If years is increasing, automatically the salary was increasing. So the behavior of the data sets are linear. Therefore, we are using this linear regressions for this analysis. So so these are all the 4.1 year. My salary is 57,081. Suppose if it is a 5 year, what may be the salary? So that kind of estimation we can done by using this analysis. So we have to use input and target data. Target data is also called as labeled data. So we extract the input data and the label data here. And very important thing is we have to divide the total data set into training data as well as testing data. Most probably, for training, we have to use more number of data because the system should be trained properly. And testing, we can use very less number of data. So the training, we can use 70% of our data sets for training, and 30% is used for testing data. Therefore, here you can see simply training x train x test, y train y test. The train test split by x by test. Then test size is 1/3. The test size 1/3 means the 1/3 of the things is only giving for test, and remaining is given for that training. So that is the thumb rule for dividing our data sets into training as well as the training as well as testing. So this is the dividing the data set. Training and testing is over. The next is, yeah, this is the test data sets, and this is the training data sets. We are dividing this two into all. So my train data sets ready, my test data set ready. Now we have to give this data sets into our regression model. So first we can scikit learning functions is containing all kind of machine learning algorithm. We don't want to write the whole algorithm. Simply we can use this functions for our purpose. So linear regression is our things. So we can make linear regression to the regressors for the fitting. That means making the relationship between that one, the x train and y trains, or making the relations of regress fit. Exactly, this regress fit is the uh, key command line for our Python programming. And prediction of data set, we have to predict the data sets by using the same regressive predict only. So this will be y prediction, and x predictions will be given here. And first we have to visualizing the training data sets. Here is a plot and title, label, x label and y label, and scatter. We are going to scatter into green color. We are going to plot the training data by red color. So here you can see the scatter will be training, and red will be the predicted. So the predicted value. So the predicted values here, this is a trained value. The predicted and trained values almost, they are going to train until they are reaching all are in line. We have to train number of iterations. If you are increasing, automatically the training efficiency also increasing. So next one is validation plot. Whether our system is good or bad, that validation, but that validation is calculated by testing our data sets. So the test data sets, we are passing this one in by scatter plot our test case and trained one, and finally we are giving title and label and x label and y label of this function. So here you can see my blue lines are this is the trained data, and this is the estimated or predicted data. So predicted data line is red color, and training data are data sets are test data. Sorry, this is a test data. It's a test data are in blue lines. So you can see most of my data are is fit with my predicted data one. So the system is approaching very good one. Suppose if all the data are scattered is not fitting, means whatever we design the system is not correct. So the behavior of data sets also linear, and we are using linear regressions so that we can use this as a validation. So our system model is very good enough. And core of the code, the 3 lines is enough to complete code is enough. So remaining for simply extracting the data and importing the library, and splitting the data sets for training as well as testing. So this is the core of the code. And limitation of the linear regression is that it can operate only the linear dependency and the gradient descent. Sometimes it leads to the very great delay. So these are all the limitation of linear regression. How the limitation will be overcome is that suppose if the data is non-linear, we can use polynomial regressions, and its convergence speed also is much more greater than the linear regression. So this is a remedy for non-linear data set behavior. And conclusion is, yes, the linear regression is the type of machine learning algorithm, and it's a supervised machine learning algorithm specifically. And mostly supervised learning algorithm is calculating the predicted value by labeled data sets, and is providing optimized linear function. So we can, whatever our prediction is, exactly match with the test data. So so it can be useful for wherever for example, weather forecasting and the salary and selling price calculation, everything we can done by these linear regressions. So I hope you may enjoy with the practical and theoretical mathematical approach of this linear regression. Thank you so much for your passionate listening. Thank you so much for giving this chance for me. Thank you. Thank you for everyone.